All right. So looking at number 1, it says, you flip 2 coins. What's the probability of landing on a heads and a tails? So we have 2 coins. Now remember, we only have 2 coins. We have 1 coin, 2 coin. Now it says, what's the probability of landing on a heads and tails? So our outcomes are heads and tails. So if we flip this first coin, we can land on a heads and tails. On the second coin, we can land on a heads or a tails. So what we're going to do is make a tree diagram to list all the possible outcomes. So on our first toss, our first coin, we're going to get a heads or a tails. And now we're going to branch out from there. So now event 1 has taken place. Moving on to event 2. We flip. Let's say that we landed on heads on the first flip. On our second flip, we'll either land on a heads or a tails. So the order, we could have landed on heads then heads, and we could have landed on heads then tails. So then from there, well, let's say on our first flip, we landed on a tails instead of a heads. Well, on our second flip, we're still going to land on a heads or a tails. Now, this is only 2 coins. So now we've listed our 2 coins. This is only 2 coins. A lot of you went out and did 3 coins. You did another heads and tails. But that would not be true for this one. On the test review, we had 3 coins. This one's just 2 coins. So this is where you'd stop. All right, so then if we would have landed on tails, we could have landed on tails then heads, and we could have landed on tails then tails. So the total possible outcomes would be 1, 2, 3, 4. So our total possible outcomes is 4. Okay, so now let's answer the question. What's the probability of landing on a heads and a tails? So let's look at our outcomes and see where we land on a heads and a tails. Right here we land on a heads and a tails, and right here we land on a tails and a heads, which is still a heads and a tails. So that happens 2 times out of 4. So there's a 2 out of 4 chance, 2 out of 4 outcomes are going to land on a heads and a tails. So that's equal to 50%. Okay, so it says you flip the same 2 coins, but the probability of landing on heads this time is 1/3. Then what is the probability of landing on a heads and a tails? So first of all, we'll use the same tree diagram as above and list out our sample space. So we have heads, 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 tails, tails, heads, and tails, tails. But this time we have a weighted coin. The chances we land on heads is 1 out of 3. So if we toss a coin in the air 1 out of 3 times, we're going to land on heads. Well then, the only option is landing on tails. If we're not landing on heads, we must be landing on tails. So if 1 out of 3 times you land on heads, then 2 out of 3 times we must be landing on tails. Alright, so looking at this, it says, what is the probability of landing on a heads and a tails? Well, where does that happen? Right there and right there. Well, let's find the probability of landing on heads and tails. Well, the probability of landing on heads is 1/3. The probability of landing on tails is 2/3. So right there, that's the probability of getting heads and tails. But we also have this tails and heads. The probability of landing on tails is 2/3. The probability of landing on heads is 1/3. So it happens in 2 places, these 2 places. And the probability of each event happening, if we take our calculator and multiply it out, we're going to get right here 2/9, and right here we're going to get 2/9. All right, so now if it happens in those 2 places, then we've found the probability of each thing happening, so now we'll add those up, because that's the total number of times we get a heads and a tails. So you do 2/9 plus 2/9, and that's equal to 4/9. So I would want that answer, as well as if you do that in your calculator, you'll get 44.4% chance. So both of these would be correct. Okay, so it says, list all the possible outcomes of the summing of 2 6-sided dice. Now, summing means we're adding up. So outcomes is if we take 2 dice and roll it and then add up what we get. So let's list all the possibilities here. On our first dice, we can roll a 1, a 2, a 3, a 4, a 5, or a 6. So on our first dice, these are what we could roll. On our second dice, we can roll a 1, a 2, a 3, a 4, a 5, or a 6. So same thing here. Think about it in real world. If you rolled 2 dice, you'd land on a 1, or a 2, or a 3, or a 4, or a 5, or a 6 on the one dice, and on the other dice, you'll still roll a 1, a 2, a 3, a 4, a 5, or a 6. But now our outcomes is if we add those up. So I'm just going to fill in my lines to keep this nice and pretty. But we don't have to fill in the lines if we just keep it really organized. Okay. All right, so let's fill it in. So 1 plus 1, a lot of people multiplied. It said the summing of two 6-sided dice. So 1 plus 1 is 2. And then if you add these, it will go as follows. All right. So now we're going to be finding probabilities. So to find probabilities, we're going to need totals. So how many total possible outcomes? You will add up 1, 2, 3, 4, 5, 6, 7, 8, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36 total. So total is 36 possible outcomes. All right. All right. So now we'll answer the question. It says, on number 4, it says, describe the event that the summing of the two rolled dice is larger than 7 and even. So this one's and. So this one we're going to compare. Well, and means intersection. So where is it the sum larger than 7 and also at the same time even? So it's got to be these two things at the exact same time. So if you look in here, where does that happen? Well, things larger than 7 would be all of these, right? So 8's larger than 7, our 9's are larger than 7, the sum is larger than 7, 10, 11, and 12. These are the ones that are larger than 7. All right, so with that being said, which ones, how many, does it come out to be larger than 7 and at the same time even? So at the same time even. So that would be our 8's. That's larger than 7 and even. That would be our 10s, larger than 7 and even, and 12. So if you add those up, you get 1, 2, 3, 4, 5, 6, 7, 8. That happens 9 times out of 36 times. So that's our probability, 9 out of 36. And we would write both answers, which is 25% of the time. Now this next one, it says, rolling a sum larger than 7 or even. So since it's or, we know that this is the union. Or is friendly. So it gets to come if it's a sum larger than 7 or even. So or means both are welcome. So all the ones larger than 7, and we've already highlighted all of those. Those are all larger than 7. But now or evens get to come. So 6 is an even, 6's are evens, that's where the sums are even. 4 is an even, and 2 is an even. So now if you count up how many times that happens, then we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 times. That happens 24 times out of 36. And if you take that on your calculator and do 24 divided by 36, you're going to get 67%. So that's the difference between the two. Notice how they're very different. Okay, so using the same sum, I already have it listed over here. You'll just look up and use that same one that you used on number 3, because we're dealing with that again. On number 5 it says, what's the probability that the sum of the two dice will be greater than 8? So let's see where that happens. Where will the sum of the two dice be greater than 8? Well, right there, 9, 9, 9. Those are greater than 8. Those are greater than 8. The sum's greater than 8. Right there. So how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of 36 times that happens. So 10 out of 36. If you do that in your calculator, you get 27.7. So your answers are multiple choice. There's a 27% also on there. But what would be more correct? If there's a 28%, wouldn't it be more correct to say 28% since 27.7 would round to 28? Yes. Okay, so now number 6. What's the probability that the sum of the two dice will be greater than 8, given that the first dice is a 6. So this one's a little bit trickier. This time we're given that that we're given that the sum of the first dice is 6. So what I would have listed is that we had a 1, a 2, a 3, a 4, a 5, a 6. Hold on just a second. Okay, there. So it's easier when you have those dice listed out on the top. Okay, so it says, what is the probability the sum of the two dice will be greater than 8, given that the first dice is a 6? So if you look at your first dice, that would be this top row. So this time we're given that our first dice is 6. So we're looking in this row right here. Given that the first dice is 6, now let's determine what's the probability that the sum will be greater than 8. So right here, it starts where it's greater than 8. Right, there's greater than 8, that's greater than 8, and that's greater than 8, and then so is 12. So that's 1, 2, 3, 4 out of 36 times. So 4 out of 36. So this time, once again, we were given that the first dice is a 6, so that would have taken us to this row right here, and there's 4 times where our sum is greater than 8. So 4 out of 36, if you would have done that in your calculator, you'd get 11.1, and then you change it back to a fraction, and that's 1/9. So our answer would have been 1/9. Okay. So let's do number 8. So it says, you decide to tell your fortune by drawing from a standard deck of 52 cards. You're drawing 2 cards from a standard deck of 52 cards without replacement. Now that is the important part. So without replacement. Without replacement. So these are dependent events. So it says, what's the probability of drawing first a queen, then a jack? So our first event is a queen. Our second event is drawing a jack. Well, these are dependent events, and we know that to find the probability of 2 or more dependent events happening, you take the probability of event 1 times by the probability of event 2, given that event 1 has already occurred. Okay, so let's go through and find these probabilities. So first of all, what's the probability of first drawing a queen? Well, in a standard deck of cards, how many queens are there? 4. So there's a 4 out of 52 chances, a 4 out of 52 chance that we'll draw a queen on the first draw. So now let's say that we drew out a queen. So there's no more queen in there. There is 3 other queens, but we took out one of the queens. Well, now how many cards do we have? We don't have 52 because we're not replacing it. Now we only have 51 cards. Okay, so now we can move on. What's the probability of then drawing a jack? Well, how many jacks in a standard deck of cards? There is 4. Okay, awesome. So this is the probability of event 1 times by the probability of event 2, given that event 1 has already taken place. So you'll take your calculator, you'll multiply those out, and you're going to get 0.00603. And we know we move our decimal 2 places to the right, so 1, 2. So that would be 0.603% chance. Okay, now I'm going to do number 9. In a shipment of 20 computers, 3 are defective. If 3 computers are randomly selected and tested, what's the probability that all 3 computers are defective if the first and second are defective? So we're not going to put the computer back in and then we're not going to replace the computer once we've chosen it. So this is dependent events. So once again, well, first of all, how many total? There are a total of 20 computers. Now, if we had to, we could draw out 20 computers. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. And 3 of them are defective. So I'm going to call defective, defective, defective. Okay. So now we're going to go through and find the probability of selecting 3 and that all 3 very first were defective. So let's look here from the very beginning. On our first pick, what's the probability of drawing a defective? How many defectives are there in the beginning? Well, there are 3. So there's a 3 out of 20 computers, a 3 out of 20 chance that we would draw a defective on the first draw. So now we've drawn a defective. All right, so now there's only 19 total in there. Well, how many defective, if we want to know about drawing a defective on the second draw, now how many defective are in the batch? Well, only 2. All right, so let's say that there's only 2. Okay, so now we've drawn another defective. Well, now, okay, so now there's only 18 total computers. Well, now what's the chance of drawing that defective? Well, there's only 1 out of the rest, 1 out of 18 chance on that third pick. Okay, so now this is the probability. We multiply these, right? This is the probability of event 1 times by the probability of event 2 given that event 1 already took place. And then this is the probability of event 3 given that those 2 events already took place. Okay? So now you'll multiply those out and you're going to get, if you multiply it out, you get some weird answer. Well, a lot of people feel like it's weird, but it's really not that weird. You get 8 point something, and then it says e to the negative something. E to the negative 10 or something. What that just means is, we won't get into that right now, but that just means times 10 raised to the negative whatever power it is. So now, if you try to change it back to a fraction on your calculator, it won't let you, but you would just take all those answers. So take answer A, and that's 1 over 25, 1 over 125, test it and see if it's the same answer as your answer. So if you divide 1 over 125, you don't get the same answer that we got right here. If you take 3 over 20, you do not get the same answer that we got right here. If you take 1 divided by 1,140, then you get the same answer that we got right here. So our answers are the same, so they must be the same. So our answer is 1 over 1,140. All right, so in a library box, there are 8 novels, 9 biographies, and 7 war history novels. What's the probability of drawing first 2 novels, then a biography, then a war history novel? Okay, so first of all, to be able to find probabilities, we have to know the total. If we add up 8 novels, 9 biographies, and 7 war history novels, we get a total of 24 books. Okay. So now it says, what's the probability of drawing first 2 novels? Well, we can't work in twos. We've got to work in ones. They're going to ask it to you like this to see if you know that. All right, so we have to work in ones. So what we're really wondering is, what's the probability of drawing a novel, then a novel, because that's 2 novels, then a biography, then a war history novel? Well, these are dependent events since we're not putting them back. So we just go through them individually, being really careful. All right, so what's the probability of drawing a novel on the first draw? Well, there's 8 novels, so there's an 8 out of 24 books. 8 out of 24 books that will choose a novel. All right, so now let's say we chose a novel. Now there's not 8 novels, there's only 7, giving us 23 total now. All right, so now what's the probability of drawing a novel? It's 7, okay? So there's a 7 out of 23 chance of drawing a novel on our second draw. All right, moving on. So now we've drawn another novel, so there's only 6 novels. All right. So now there's only 22 books total because we've drawn 2 novels. All right, now be careful. We want to know now what's the probability of drawing a biography. Well, how many biographies are there left in there? 9. So there's a 9 out of 22 chance of drawing a biography. And now instead of 9 biographies, there's 8. So how many total? There's 21 total. And the last thing is then a war history novel. Well, in that group of 21 books, how many war history novels? 7. All right. So now I've had a few people say, well, what do you do with those? You multiply them. Remember, this is the probability of event 1 times by the probability of event 2 given that event 1 already took place. And then we take times by the probability of event 3 given that event 1 and 2 already took place. And this is the probability of event 4 given that 1, 2, and 3 have already taken place. So yes, we multiply. That's how we find the probability of 2 events happening is multiplying. In this case, they were dependent. Same thing though. You multiply to find the probability of 2 or more. So in this case, there was 4 events happening. And if you do that, you get 0.0138. And so you move it 2 decimal places, and that would be 1.38. And it says to round to the nearest whole percent, so we would round to 1%. Okay, looking at this one, Number 11 is we're given a sample space, I love you, and we have event A, which is a subset, is love, and event B is you. So we're going to make a Venn diagram. So in event A, we have the letters L. It's not in B, it's only in A, so it's going to go right here. We have an O, it's also in B, so it's got to go in the middle. And then V is only in A, and E is only in A. So now we've taken care of A. Let's move on to B. So B has a Y, so this is event B. B has a Y, and it's not an A, and it has an O. We've already taken care of that, and a U. All right, so we've taken care of B. Now you have to check your sample space. I was in the sample space. It's not listed in any of these circles, but it's still there. It's floating on the outside. So now we've filled this in accordingly. So now I'm going to cross all that out. In fact, I'm going to erase it now, so I have room. All right, so now let's do this one. Find A united with B. A union B. So if it's in A or B, it gets to come. So A union B means in A or B. So that would be L, V, E, O, Y, and U. That's in A or B. All right, now A intersect B. This is only in the intersection, and it's easy to see with the Venn diagram. So in the intersection of A and B would be O, sorry. This would be O. All right, now let's find A complement. That means everything not in A. Well, be careful because all of these are in A, but also that's in A, so that can't be in the complement. So that means that I, we won't forget I is not in A, and also Y and U. All right, so now let's do B complement. Complement of B. So B complement, that little squiggly means complement. Everything that's not in B, be careful, that's in B, that is in B. So everything not in B would be I, L, V, E. I, L, V, and E. Those are not in B. All right, so continuing this onward here. Okay, now let's find the complement, that's squiggly, A union B. So the complement of that, well, A union B is all of this stuff right here. So what's everything that's not in that union? What's not in A united with B? The only thing that's not in that, because that's what complement means, the only thing not in that is I. All right, let's find the complement of B intersect A. Well, that's right here, right? So what's everything that's not in that? An I, an L, a V, a E, and a Y, and a U. So everything that's not in that intersection, the complement. All right. Now let's find the probabilities. So this time it's asking us to find, now this is important, the probability of A united with B. To find the probability, we need total. How many total letters do we have in our sample space? 1, 2, 3, 4, 5, 6, and 7. There's 7 in our sample space. Okay, so the probability of landing in A union B. A union B would be 1, 2, 3, 4, 5, 6. There's A union B means everything in A or B, so there is 6 out of 7. So 6 out of 7 that will land in A union B. Then the probability of A intersect B would be A intersect B is right here. So what's the probability of A intersect B? Well, there's 1 out of 7 chances will be in A intersect B. So hopefully you understand those probabilities. So let's do the probability of the complement of B. So that means everything that's not in B. So everything that's not in B would be 1, 2, 3, 4 out of 7. All right, 4 out of 7. All right, continuing. All right, number 12, it says, let's go through and find these probabilities. So we're given this table. Well, looking at it, we're given that it says that a study was done on what fast food places at different age groups prefer. These were the findings. So in age group 1 through 15, there's 20 that prefer McDonald's, Burger King, Wendy's, 12 that prefer Taco Time, and so on. All right, so to be able to find these probabilities, we have to know the total. Well, just total them up. Don't make it harder than it is. There's 20 plus 24 plus 14 plus 12 plus 7, plus 9, plus 12, plus 16. So there's a total of 114 people total. All right, so find the probability that they're in age group 1 through 15. So where does that criteria meet? Right there, right there, right there, right there. Those are all in age group 1 through 15. If you add up 20 plus 24 plus 14 plus 12, you're going to have 70. So there's a 70 out of 114 chance that we would land in that age group. And yes, I need both answers. So 61.4%. All right, what's the probability that they prefer McDonald's? Well, look in your group. Where do they prefer McDonald's? Right there and right there. So 27. So there's a 27 out of 114 chance that they prefer McDonald's, which is 23.7. All right, now let's do the probability of 16 to 30 and keyword and Burger King. So this one is the intersection. Where do those things intersect? Where are they 16 and 30 and at the same time prefer Burger King? So if you look 16 to 30, that would be this row, and that intersects with, we need it to intersect with Burger King, so that'd be that row. So the only place where we get age group 16 to 30 and at the same time prefers Burger King is right there. So that's 9 out of 114. So 9 out of 114 is 7.89%. And then the probability of 16 to 30 or Wendy's. So or means if they're in either or, they get to come. So ages 16 to 30 would be all of this, or prefers Wendy's. That would be all of this, right? So all of those get to come out of 7, 9, 12, 16, and 14. That would fit in 16 to 30 or Wendy's. If you add those up, you get 58 out of 114, which is 50.9% chance. All right, so hopefully you understand the difference between and or, very different. All right. So looking at number 14, the probability that a student passes the written portion of the driving test is 62%. The probability that a student passes the driving test is 86%. So I'm going to make a tree diagram. So there's a written exam and a driving exam. Now they either pass or fail. Pass or fail. They either pass or fail. Both the driving and written portion. Oops. Okay, so now it says the probability that people pass the driving test is 62%. So the pass rate of driving is 62%. Well, then what's the fail rate? 38%. All right, also it says the probability that a student passes the driving test is 80. Oh, I read that. I wrote driving twice on here. The second one is written. The first one was written. Dang it. First one was written. Typo in my thing. This one was the probability that this one's written. So the probability of passing the written test is 62%. So the fail rate of the written is 38%. Okay, there we go. And now the probability of a student passing the driving portion is 86%. So there's an 86% pass rate of driving, so then there must be a 14% fail rate. Okay, so now it says, what's the probability that a student will pass both the written and the driving? So the probability, these are just independent events. We take the probability of event 1 times by the probability of event 2. The probability of event 1 would be passing the written test, which is 62%. So we write it as 0.62. The probability of them passing the driving test is 86%. So 0.86. This is event 1, this is event 2. It was pass. So you take those, you multiply individual events, and you get 53.32% chance. So let's say I said round to the nearest whole percent, that would be 53% chance of passing both tests. All right, now this is the last one I'm going to do. Dice 1 has 3 1s and dice 3 has 3 6s. Dice 2 has 2 2s and 4 5s. So this is a weird dice, but that's okay. So what we're being asked is, if the dice are tossed, with the dice with the highest number wins, which set of dice is more likely to win? So what we're going to do is calculate the expected value here. So with this one, I don't know, it threw people off, but dice 1 has 3 ones. So if we need to do that, 1, 1, 1, and 3 6s. So there's a 6, and a 6. Okay. And then dice 2 has 2 2s and 4 5s. 1, 2, 3, 4 5s. Okay. So now look, there's 6 total here, 6 total here, and there's 6 total here. Okay, interesting. All right, so let's calculate the expected value of dice 1. All right, well, first of all, the expected value is what we would get if we landed times by the probability of landing on that. So we would get a 1 if we land right here. What's the probability of landing on 1? Well, there's a 3, 1, 2, 3 out of 1, 2, 3, 4, 5, 6 chance. So there's a 1 times 3 out of 6 chance. All right, and then plus 6, we could land on a 6. And what's the chances of landing on 6? 1, 2, 3 out of 6 chance. So if you calculate that, that's your expected value. You could land on a 1, and there's a 3 out of 6 chance, plus you could land on a 6, and there's a 3 out of 6 chance. So if you do that, you're going to get 3.5. That's what you can expect to win on each roll. It's an average. Remember, expected value is just an average amount you can expect to win. Okay, so we could land on a 2 with this dice, and what's the chances we'll land on 2? Well, there's 1, 2 of them out of 1, 2, 3, 4, 5, 6. So there's a 2 out of 6 chance of landing on a 2, plus we could land on a 5. And what's the chances of landing on 5? 1, 2, 3, 4 out of 6. Okay, so that is what we can expect to win on average for dice 2. If you do that, you get an expected value of 4. All right, so which expected value is higher? This one. So you can expect to get a 4 on average with dice number 2 and a 3.5 on dice number 1. So dice number 2 has a better likelihood, a better average of winning. On average, you win more with dice 2. So your answer for number 15 would be dice 2. And that is the end of the video.